Hi, welcome to another ASMR video tutorial for math. In this video lesson, we will look at solving equations with one unique variable. The difference between an expression and an equation can be expressed in two words: equal sign. Expressions don't have them, but equations do. That one little symbol makes a huge difference. For one thing, your overall goal is different. You previously have simplified equations writing the same expression in a different, usually shorter way. Equations are easier to deal with than expressions because you actually get a tangible numeric answer, one that you can go back and check to make sure you got it right. In this video, start out with basic equations, solving techniques, and they'll slowly evolve, becoming more and more complicated by the end. You should be able to solve just about any equation. If there's only one unique variable in the equation, like x, and that variable is raised to the first power. 5 more than a number is 13. According to this problem, the more than in this context indicates a sum. So 5 more than a number is expressed as x plus 5. The phrase is equal to indicates the presence of an equal sign. So the algebraic equivalence of the 5 more than the number is equal to 13 is x plus 5 equals 13. We now would need to solve this equation by isolating the variable. Isolating a variable means that you get the variable all alone on one side of the equal sign by itself. So we would be moving numbers away from the variable. In this case, we would be moving 5 away from the variable x. When we are moving numbers, we have to do the opposite operation. So we would need to subtract 5 on both sides of the equal sign. This would make the 5's cancel. 5 minus 5 would be 0. But as highly skilled mathematicians, we don't need to write it. X equals 13 minus 5 is 8. And that's solving a linear equation. You can confirm the accuracy of any solution by taking your answer and substituting it back in for the variable. Let 8 be x. 8 plus 5. Does that equal 13? 8 plus 5 is 13. 13 equals 13. So we were correct. Example 2. Negative 6 equals x minus 19. Isolate the variable by doing the opposite operation and add 19 to both sides. Once again, negative 19 plus 19 is 0, and that cancels. We don't write 0 because we're highly skilled. Negative 6 plus 19 will give us 13 for x. We check our solution by substituting this in. Is negative 6 truly equal to 13 minus 19? 13 minus 19 is negative 6, which equals negative 6. So our solution is correct. Example 3. Now we have the variable on both sides of the equal sign. We have a choice to make. We need variables on one side together and numbers or constants on one side together. Some people made the choice to always put their variables on a particular side no matter what. Perhaps you want your variable to always be on the left. And some people use a different strategy altogether where they try to avoid negatives. It doesn't matter as long as your moves are accurate. I will be moving x to the other side. I will do the opposite operation and subtract x on both sides. These x's, x minus x, will be a 0, which I will not write. 2x minus x will be x, and we'll bring everything else down. Plus 1 equals negative 3. Now this problem looks a lot like what we've done before. We want to isolate this variable x by subtracting 1 on both sides. The 1's will cancel. X equals negative 4. In this example, we can see the introduction of parentheses into the problem. We also see variables on both sides again. It's very important that we simplify each side as much as we can before we get into moving items from side to side. You first want to use the distributive property and take the 6 through the parentheses. 6 times x is 6x. 6 times a negative 1 is negative 6. We'll bring down everything that was there before, like the 5 and the plus sign and the equals 11. plus 5x. But there's more to do to make this problem be simplified. 5 and negative 6 will become negative 1. Bringing down their 6x equals 11 plus 5x. And now we're ready to have our variables on one side and our numbers on the other. I'll choose to subtract 5x on both sides of the equation. We know this will cancel, leave us with 11 equals negative 1, and 6 minus 5x is just x. Notice, as a highly skilled mathematician, I do not write the 1 in front of this x, as it is completely unnecessary. One more step to get x isolated is to add 1 to both sides. The 1's will cancel. X equals 12. As we continue solving linear equations involving adding and subtracting, we see that our problems get increasingly more difficult. Our previous example had parentheses. Now we have 2 sets of parentheses in this problem. We take the number on the outside and multiply it by each number inside the parentheses. So we get 4x plus 28 minus 18 equals, we repeat the process over here. 3 times x is 3x. 3 times 10 is 30 plus 6. At this point, we want to simplify each side. 28 minus 18, these are like terms, will give us 10. 30 plus 6 is 36. And we are yet again at the point where we need variables on one side and constants on the other. We will subtract 3x from both sides. Our 3x's will cancel, leaving us with 36. 4 minus 3x is x. No need for a 1. X plus 10 equals 36. Subtract 10 from both sides. And x equals 26. In this portion, we will be using multiplication and division to solve an equation. We still want to use the opposite operation to undo the equation and isolate the variable. So to remove the 3, we will do the opposite and divide both sides by 3. We did this because originally this was multiplication between the 3 and the x. So the opposite would be to divide. 3 divided by 3 is a cancellation that leaves us with just 1. But as highly skilled mathematicians, we won't write 1x, we'll just write x. then 42 divided by 3 would be 14 as our solution. Once again, you can always check your work by substituting the 14 back in for x. There are several ways to view this next example. Some people look at it as 2/3 times x equals 24. And some view it as 2 times x divided by 3 equals 24. The choice is yours to make. I like to view all fractions as division problems, and to understand that we truly have 2 times x divided by 3. So to solve this problem, I'm going to undo the divide by 3 by multiplying both sides by 3. Of course, we have 3 divided by 3 is a cancellation, and it leaves us with 2x equals 24 times 3, which is the 72. Now we simply can divide both sides by 2. Our 2's would cancel, and x would equal 36. Some equations look like this, like fraction equals fraction. We really call this proportion. And on these cases, we simply want to multiply along the diagonals. X times 6 would be 6x. And once again here, 1 times 9 would be 9. Solving this resulting equation, we divide both sides by 6. And we know the 6's would cancel. So x could be 9 over 6, or we could reduce it, reducing it down to 3 over 2. You could even change it to a decimal if you like. But why would you want to do something like that? In this next proportion, the variable is in a different location, but the process is the same. We'll cross multiply. 5 and 7 is 35. And x times 2 is 2x. Isolate the variable by dividing both sides by 2. Our 2's cancel, and x is 35 over 2. In this case, we can't reduce, but you could change it to a mixed number or a decimal. Sometimes we get equations that require us to perform multiple steps in order to solve. In this case, we always want to follow the reverse order of operations when we are isolating our variable. So we will subtract 3 first on both sides. get 4x equals 24. Divide both sides by 4. And x equals 6. This problem involves parentheses and fractions. And fractions I don't particularly like to see in problems. So I control my destiny by removing the fractions because I have the absolute prerogative to do so. In order to remove fractions from this problem and rewrite it in a way that I would like to see it, I multiply the entire equation by the denominator that I see. In this case, I'll be multiplying the equation by 3 because I see 3 on the bottom of these fractions. So I will multiply this entire equation by 3 and here as well. I'll be distributing this through. 3 times 1/3 is going to cancel, which is my whole purpose of doing it, and leave me with x. Voila, no more fraction. Same thing here, 3 times -8 is -24 equals 3 times 5/3. My 3's will cancel and I'll be left with 5 times x plus 6. This problem looks so much better to me. I'm ready to solve it now. 5x plus 30 x minus 24. And now, getting the x's on the same side, I choose to subtract x. That leaves me with -24 equals 4x plus 30. So I'll subtract 30 on both sides and I'll get 4x equals -54. Divide both sides by 4 and x will be a reduced improper fraction here of -27 over 2, which could be changed to a decimal or a mixed number.